Hello, this is James T. Kahn, and today we're going to look at basic collision detection using the bullet physics library. So for this tutorial, we won't have any rigid body dynamics or anything like that. All we're going to have is the basics because with bullet, you got to walk first before you run. So what we're going to do is create this, what you see here, which is just, we're going to have a bunch of random shapes that are going to fall. And then we're going to detect, or we're going to use bullet to detect when these shapes collide with this floor here. And I'll just run the simulation here. So when they collide with the floor, we'll change the color of the shape to red. And of course, we'll stop moving the objects once they've reached the bottom. And then we can take a look at the objects here, at a couple different random rotations. And we can just make sure that, hey, the objects stop at the right spot when it collided, because all these objects use collision shapes. And if your collision shape is not lined up properly with your model, then the collisions are going to be off. So this is a good way to check, hey, are my shapes lined up right? Like for example, a cone here stopped right where it should have on the point. So we know that cone shape for the collisions is good. So let's go ahead and get started with the code. For this tutorial, I'm going to be starting off with a freshly generated libGDX project. When you generate a project using the generator here, you can check this box and that'll include the bullet dependencies that you need. Let's say that you didn't do that and you need to add bullet to your project manually. To do that, if we head over to the libGDX wiki here, the bullet wrapper is set up, and then we can click here to get the instructions for adding the dependencies manually. Now we'll need the core dependencies, so I will copy that and head over to our core here in Gradle, core project. And then we'll also need the desktop natives. Copy it and bring it over to desktop. Now there's also dependencies if you're using Android. For this tutorial, I'm not using Android just because I want the code base to be as simple as possible so that anyone can run the code even if they don't have the Android SDK set up. So if you wanted to have Android, or if you're using Android, then you would want to include these dependencies as well. So next step, if we head over to the bullet physics, so this is just my application adapter. This is the default application adapter class that gets created. So it's kind of our entry point on the libGDX side. So if I run this right now, we get that default, screen with a sprite patch here. First thing we want to do is initialize bullet. And this is the method you'll be looking for here, just bullet.init, a static method. If you try to make any other calls to bullet before you initialize it, then you're going to get errors. It's going to, it'll throw an exception and it'll say that, I can't remember what the error is right now. But yeah, if you don't initialize bullet, you'll get an error. It's a common thing to miss. And next, I'm going to remove all these other things that we don't need in here. These just default generated items. Okay, so we have our create method. Another change I'm going to make is I'm going to extend game instead. And I think game is just an implementation of the application listener. And now what we can do is if we head to sources and I'm going to create a new package here, and we'll call that screens, because we're going to create a new screen. And in that screen, let's just call it the basic collision detection screen. There we go. And this is going to, actually, we'll hold off. We won't extend anything here yet because I have something else in mind. But let's do one piece at a time. So if we go back to this bullet physics, so our entry point, our game class, we initialize bullet, and then we're going to call this set screen method. And just put new bullet physics. And, not bullet physics, we want new basic collision detection. So that's our screen class that we've created. It's going to cause an error because it hasn't extended from screen or screen adapter yet. And we can fix that now. So we're going to have another class, and we're going to call that base screen. Now what I'm doing here is for the purpose of the tutorial. So if you're making a game and you're following this, just keep in mind the architecture that I'm doing right now is purely for tutorial purposes. So if you're following along, I just want you to keep that in mind. This might not be what you want for an actual project. So this base screen is going to extend screen adapter. And now if we go to the basic collision detection, we will extend our base screen. And there's a reason why I'm doing that, because I'm going to have multiple screens down the road for these different tutorials. So this base screen is going to just hold a lot of the basic rendering and things like that I'm going to need for every tutorial. So that's the idea behind that. So I'm also going to bring in one other dependency, and that is VizUI, which is UI library. And I'm going to do that just because it's easier. I don't have to worry about skins or anything. It's kind of just a shortcut for me to, if I want to display some labels or anything, I can just bring VizUI in and I can do that. So I'm just adding in that dependency in the version for it. And let me refresh Gradle here. All right. Now for the base screen, what I'm going to do is I'm actually going to bring over a bunch of code I've already created. And that's just to prevent the video from being an hour long. So, you know, the code I'm bringing over here is, there's nothing special happening here. It's pretty vanilla, standard libGDX stuff. Let's see. Oh, yeah. So I'm going to just create a constructor here is what it's worried about. There we go. And then this also. So I'll explain this in a moment here. Oh, yeah, this is going to take this. Okay. So this base screen, I've added this constructor that takes in the main game object. This is just good to have if for later on if I want to switch screens. So that's just a basic explanation of what's going on there. So from our bullet physics class, when we call new basic collision detection, we're passing in this as the game object. And for now, this is just the constructor going to the parent base screen class. I will very quickly just go over what this class is doing. But again, I'm trying to focus on bullet here, and this is just basic libGDX APIs and 3D rendering. So very quickly, what we have a perspective camera, first-person controller. We have a model batch. We have a shadow batch, both model batches. And I'm going to have this array of model instances, and that's what anything I want to render, any model instance I'm going to render, I'm going to add to that array. Environment, you know, again, these are basic things. I really don't want to go into them here. But if you take a look, I'm just initializing VizUI. Get our camera going, set up our environment, stage so that we can show an FPS label and maybe some other things down the road. We initialize our model batches, a shadow batch, and create or initialize our array. Got our first-person camera controller and some random colors in this colors array just to add some variety. Then this method create axis. I actually took this from the libGDX tests, and this is just going to add a 3D grid on inside our scene, a 3D grid, and it's just nice to have that for reference, for a scene of reference, just to see, okay, that's up, that's down, left, right. So that's why I like to have the axis there. So again, this just comes straight from the libGDX tests. I think I modified it very slightly. And then I got a method here to get a random color. So nothing crazy here. In the render loop, we just update our camera controller, clear the screen, run our shadow batch, so we get some basic shadows, and it's only going to stay at the center 000 position. And then we render our model instances, act and draw our stage, and then we just update our FPS label with the current FPS. So if we now try to run the project, we should be able to see that 3D grid that I was talking about. If you take a look here, we have the grid up and running in the first-person controller, so I can move around. I'm going to head over to our desktop launcher. I'm just going to make a couple changes that just makes it look a little nicer. So this back buffer config. Bear with me a moment. So I'm going to, we can use the, I think we can get away with the default depth. And then for samples, just give us a little bit of anti-aliasing here. And I'm also going to change the windowed mode and make it kind of a widescreen instead. Just 1280 by 720. And let me check that real quick. That looks a little better. Okay. And again, for this base screen, I know I just copied this code over. If you need to get this code, if you're following along and you're coding along, I will have this code pushed to a repository, and I will link to the GitHub repository in the description of the video if you want to grab this code. Now we're going to move over to our basic collision detection, our screen, and start adding in the code for this tutorial, which is to do that basic collision detection that you saw at the beginning. And if you've gone through these Zappa tutorials, some of this is going to look very familiar. I'm going to be doing something very similar to what is done in this tutorial here, the part 1. So if you've gone through this tutorial before, you might recognize some similarities. So let's get started. Now, on our base screen, we're going to need a couple different classes from Bullet. Only a couple for this demo. And first one's going to be this BT collision configuration. I'm going to bring some comments over that I've pulled from the Bullet SDK manual, just for reference for anyone looking at this code later. So we have this class, and we have the BT dispatcher. There we go. And let me bring over the comment that I have for this one too. So very quickly, they kind of self-explanatory, but the collision configuration allows you to change and configure a couple different things about Bullet or about the collisions themselves. And then also the dispatcher is going to iterate over the different pairs of collision objects and find the algorithm that matches the shapes of those objects, and then execute the algorithm on those two collision objects. And we're going to see that, we're going to code that here shortly, but that's what the dispatcher's job is. Now, next thing we want to do is add in, I'm going to bring this over, just a static class. Now, for the other tutorials, we probably won't use this class, but purely for this tutorial, it's a little bit different. So I'm going to bring this code over, and what we're looking at here is just a very generic kind of static class called GameObject. It's extending from model instance, and it has a reference to a collision body here. And then we have this variable boolean if it hasn't collided yet. So this is going to represent, each game object is going to represent one of the shapes that we saw that we're going to have falling to the ground. And all we do is here is when the game object is instantiated, we have to give it the model to use and give it the shape. And then we can create a new collision object, which is this is another Bullet class. As you can see, all the Bullet classes are prefixed with BT. So these classes generally always correspond to C++ class. And then on this collision object, we're going to set the collision shape that was passed in. And if it's disposed, we'll call body.dispose. That's all this class is doing. And now let's head down to our constructor, because we're going to need to initialize some of these variables. Let's start off with our collision configuration. And for now, we can just use the default collision configuration here, BT default collision configuration. And for dispatcher, we'll create a new BT collision dispatcher, and we'll pass in that collision configuration. And we're also going to want an array of game objects. So let's go back up here and let's see. Game object, game objects, okay. And we'll need a reference to our floor game object so that we can check for collisions against it later. And so now we'll need to initialize that game objects array. There we go. Okay, now the next step is to create a bunch of those shapes that we're going to be using. And We'll start with just some box shapes first. I think we can do that, and we'll work our way out from there. So let's first just start with getting a single box shape rendering, make sure everything's working good there. I'm going to bring this code over because it's pretty standard code for the model, for creating a model. And this is just using our model builder. Instantiate it, we call begin. I'm just using a default material. And on that material, we're going to set a random color from that getRandomColor method. And then we create this mesh part builder here, and that mesh part builder is what we're going to use to create our box. Now let's go, so we can use the box shape builder and call it static build method. Pass in that mesh part builder. Position, we can go 0, 0, 0. For now, we'll probably change that later. And then we'll just define the size of the box. Everything's going to be 1F for float. Okay, and then we should just be able to call, let's see, model builder.end, and that returns a model for us. So let's capture that. Okay, and then yeah, we'll want to create a new game object. And what we need to pass in the model, but we still need to pass in a shape as well. So in this case, we're using a box shape. So we'll want to use a BT box shape. And that's going to look like this. And this is, so Bullet has a bunch of different collision shapes. And if I control click, I can click here. And I can look at, if we take a look, we can probably find some of them. You have a box shape, a capsule shape, there's a sphere shape, there's a terrain shape, cone shape, a lot of different shapes. We will implement some of these as we go. But if you wanted to look at the Bullet classes, you can kind of get an idea of the different shapes that are there as well. So let's take a look. The box shape takes in half extent of the dimensions. So in this case, if you look at the box, it's all 1. So all you have to pass in here is a new vector 3 and just 0.5. Okay, so now we have our shape as well. Let's pass that into this game object. And then we have our render instances array. And I'm going to add game object because remember that game object, it extends from model instance, so that's why we can add it to this array. Next, let's take a look. We're gonna, we're not gonna need to actually create a render or override the render method yet because our parent class, the base screen, already handles the rendering of these render instances. Let's see if we can run this code. Let's see if we can find that box on our screen. And here we go. So there it is. There's that box we created and looks good. Now we want to create a floor as well. And to do that, let's just create a method called createFloor. And to do that, yeah, let's head down here. Again, I'm going to grab over some code. It's that same model builder code, initialize the model builder to begin. I'm going to name it floor. And in this case now I've changed, so we're still using the box shape builder, but we're changing the width and depth here because we want it to be, a little bit larger because it's to represent, our floor. So again, we're going to want a BT box shape. And this time it's going to be, right, because the width is 20, so here the half extents are going to be a new vector 3, 10, 0.5, 10F, and that lines up with here half extents of these values. All right, and now we'll create a game object. Actually, so we want to reference our floor object, so remember we have a variable up top for that. So we'll say floor object equals new game object. Pass in the floor model, which you can see is being assigned here, model floor equals model builder.end. And then pass in our BT box shape. For the floor object, I'm going to do a transform. I'm going to translate it by a very small amount just to line it up with our grid. And then, let's see, yeah, so what we'll also want to do is update the body, the collision body that is created from our shape. And so just to explain this very quickly, we first set the transform. Now this is just going to move the floor down slightly. That's all I'm doing with this line here. Accessing the transform, translating it. Then on this next line down, I'm going to update the collision body. And if we come back and look at this, this is a BT collision object instance. And all I'm going to do is update the transform. So anytime that we update the model instance's location, we need to also update the position or transform of the collision object that's, we can say, attached. It's only attached because we're keeping it that way. So that's an easy way to get hung up on Bullet is, and we'll see this later on, there's something called motion states. We'll get into those later. But it's a challenge with any game engine is keeping your models in your collision objects aligned together, because you have your physics engine and you have your rendering, two different things. So this is what we're using. This is the glue to keep our collision body aligned up with our model. Now we're going to add, our render instances, we're going to add this floor object so that it'll get rendered as well. And let me just click play. I think they're going to be overlapping each other a little bit, but that's fine. So there we go. Now we have a floor and we've got a basic shape rendering here. No collision detection yet, but that's what we're going to start looking at now. So now we're going to want to override the render method here. And we'll still want to call super.render as well, because that's going to handle all of our rendering from the base screen class. But we want to do some update logic here. And what we're going to do is iterate over our game objects. Right now, I think we have we don't have any in our array. So this is why we have this game objects array here. So let's go ahead and fix that now. We're going to add the box that we've created to our game objects array as well. And this is just another array of game objects. But we're not going to add the floor to this one because we don't want to move the floor. So only the shapes that we want to that we want to move around are going to go into this game objects array. So now that we have that set up, we can just go for game object in the game objects array. And we'll say game object dot transform and then translate it. So all we're going to do is apply a translation on the y axis. So we just want it to go straight down. And let's see, we'll start with negative 2f times the delta. And then also, we don't want to forget to update the body, or the collision body. Set world transform to the game objects transform. Okay, if I run this right now, I think we're just going to see the cube perpetually falling. But that's fine. That's good. So we're getting there. Let's close this out. And now we're going to add some collision checks. But first, right now we're spawning the cube right on top of the floor. Instead, we're going to take that game object and let's transform it. And we'll put it at 10 height on the Y. And then also update the body transform as well. There we go. So let's just check this now. Perfect. It's above the floor. It's going to pass right through it because we're not doing any collision checks yet. Now we have everything we need to start doing our collision checks. So for the next step, I'm going to bring in some more code, but I'll explain every line and we'll walk through it here. Now this code mostly comes over from Zappa's bullet tutorial. I made a couple minor changes and added some comments to it. I think that it was this line here, find algorithm. The API has changed since that tutorial was made, so I had to add 2 new arguments. But other than that, most of the code is the same. So what's going on here is this method, check collision, takes in 2 collision objects. It wraps them in this wrapper class, which also wraps a BT collision object class. We don't have to worry about this too much. Next line, this is kind of an important part here, is our BT collision algorithm. How this works is, for each pair of shape types, right? Because we have 2 objects, so we have 2 different shape types. Maybe they're the same, maybe they're not. But for each pair of the shape types, Bullet's going to dispatch a certain collision algorithm to be used for those 2 shapes. So in this case, what we're doing is we're going to call dispatcher.findAlgorithm, pass in the wrapper for the 2 objects, and this is going to return the proper or the appropriate collision algorithm for those 2 shapes. So for example, there's this BT sphere box collision algorithm. So if we had a sphere shape and a box shape colliding and passed into these methods, more than likely this is the algorithm that would be returned. Next up, we just have a couple classes here that we're going to use to store information. Nothing special here. Then we have the call to actually process the collision between the 2 shapes. And so we call the algorithm process collision. What this is going to do is execute the algorithm and then store that result in the BT manifold result class. Now, it's going to store any contacts, any collisions in this result class as contact points. On the next line, we're just freeing this collision algorithm to, I think it's pooled from what I understand, so it's going to free it and add it back to the pool so that it can be reused later. For this variable is just going to represent if there was a collision or not. And so right now we default it to false. Then we call this result on our manifold result, get persistent manifold. And the persistent manifold is essentially a contact point cache to store contact points for the objects, if there were any. First, I check if it's null or not. And if it's not null, then I get the number of contacts. Now, if the number of contacts are greater than 0, then there is a collision between the 2 objects. So R is going to be set equal to that. Greater than 0, then it'll be true for a collision. After that, we dispose these objects, and then we return R, which will either be true if there was a collision, or false if there was no collision. Now let's head back up to our render loop. And so we're iterating over the game objects, and we're translating them down the y-axis. So now we're going to check for collisions here. So let's go down a couple lines here, and let's say if check collision, and we'll say game object dot body, and then we're going to pass in the floor object because we're going to see if there was a collision with the shape, the current shape in the floor. And we'll say if the game object has collided, continue. Then below that, game object let's get the material. Now when we created these, we only added 1 material, so we can just get the 0 index. Should be the only material on that shape or on that game object. And we're going to change the color to red. Then we'll set game object has collided to true. And continue. Okay, so once it hits the ground, it's going to hit one of these two continues, and so it's no longer going to be translated downwards. Let's try to run this. There we go. So we can see we used a bullet here to detect a simple collision. And, you know, all the collision detection we're doing right now is manual. So we're manually having to call this collision method to see if there was a collision or not. And just to show a couple different shape types, I'm going to recreate what I had in the beginning. We'll just have a couple different shape types. I'm going to copy this code over again because it's a lot of code, and I'll very quickly walk through it. So let's see, this is where we're creating that box shape. Let me remove that and just paste here. Okay, so instead now we just have two loops, a nested loop inside a loop. I'm just going to iterate so we have -6 to 6 because we're centered at 0, 0, 0 right now. And inside this loop, we're just going to create a model builder, get a mesh part builder, and then we have this shape here, and just a little bit of randomness, a switch case on a random integer. And based on that, we will create one of these 4 shapes. And let's just quickly look at this. We've already looked at a box shape, so I think we have an idea of what's going on there. For the cone shape builder, you know, it takes in a width, height, depth in divisions. And divisions is just how many times is that cone going to be divided on the faces. And then so then for the shape, we create a BT cone shape instead of a box shape. The radius would just be 0.5, a height of 1. We also have a sphere shape here. So again, the builder's pretty straightforward. This shape is also pretty straightforward, 0.5 radius. And then lastly, I'm also creating a cylinder shape using BT cylinder shape. And this takes in a half extents like the box shape does. That's just to add a little, variation to it. After that, a little bit of randomization on the height of the object and some random rotation as well. And then we make sure to update the body. And if we run this again, now we just have a bunch of random shapes. And so we can see that the shapes are working correctly and they're all colliding when they should. So this looks good. And that wraps it up. So that wraps it up for this first video. Again, this is a very simple way of doing it. We're not nearly using Bullet to its potential, but if all you need is basic collision detection, then this is the simplest and easiest way with Bullet to do that, because it's only going to get more complicated from here. But if this is all you need is just to see, hey, did these two objects collide? Then this is one approach you could use, and you could stop here without going deeper. But in the next video, we'll start looking at rigid body dynamics, where when these shapes fall and hit the ground, they bounce off the ground, they can bounce off each other. So that's what we're going to look at in the next video. But I hope this was helpful, and thanks for watching.